Hi guys, this is our notes on systems with absolute value functions. This will be a really nice review coming back from Thanksgiving break on how to graph our absolute value functions, as well as how to solve a system. So as you can see on this problem, number one, we have one equation that's an absolute value and one that's linear. And remember, the solution to a system is where the two functions intersect. So if I graph this first one, here, this is our absolute value function. This is going to have a translation to the right 2 and then down 2, so my vertex will be there. The same vertical stretch as the parent function, so up 1 over 1. So my absolute value function will look like this. Then the second function, y equals -1, is a horizontal line at -1. So I draw a horizontal line that way. I'm drawing straight lines on this is not very easy. And you can see that this intersects in two places, right there and right there. So I actually have two solutions. The first one being 1, -1. And the second solution being 1, 2, 3, -1. And remember, the solution to a system was where the two intersect, and where that absolute value function and that linear function intersect are those two places. So that would be my answer. So we look at the next one, and we notice that this one has a translation up 3, and it also has a vertical stretch of 1/3. So from 0, 0, my parent function will be 0, 0. I'm going to push that up 3. So there's my new vertex. And then my vertical stretch is 1/3. So I use that. I can go up 1/3 over 1. It's also easier to go up 1 over 3. And then mirror that point. And I can do that again if I would like to see how it fills that whole graph. Then I'm going to graph the linear function, y equals 5. Again, that's a horizontal line, which would be right there. And again, I have two places where the absolute value and the linear function intersect. So my solutions are 1, 2, 3, 4, 5, 6. 5 and 1, 2, 3, 4, 5, -6, 5. I counted the wrong way there. So that one would be 6, 5, and that one would be -6, 5. And that's all you have to do. We'll do one more example together. Make sure you're putting these examples into Cornell Notes. This one has a translation down 4. To the left 2, remember that translation inside is opposite of what it looks like. So it says +2, but it's actually going to go to the left 2. It has a reflection and a vertical stretch change. So my new vertex is going to be -2, -4. Then I'm going to use the reflection and the vertical stretch in the same thing. So I'm going to go down 2 over 1, down 2 over 1. And so we have our V there. Then y equals 4 would be a horizontal line at 4. And remember, the solution to a system is where the two functions intersect. And what we notice by this graph is that they don't intersect. They are never going to intersect. This one's going to keep going down. This one is there. So the answer would be no solution. So you can get no solution for these. And that is it, folks. That is all you're doing today. Once Mr. Williams sees your Cornell Notes, he will give you the problem set.